know where our angle is, right? And then if we're looking, then we look at the triangle.
Okay, so we can set up the triangle if we need to. So let's go for, all right, so we have weight that's going straight down.
Right.
And so whatever I'm breaking up is the hypotenuse, so then I set up a triangle.
That's where our angle.
So there's my weight. 5 as I have it labeled.
Sorry, in this situation, where is the 40 degrees?
40 degrees is that angle right there.
So we have. That's the
Oh,
hypotenuse.
I understand.
And then the bottom side would be the adjacent.
Wait, so down the ramp.
40 be the one on the top? That's
Down-
40, right?
All right, one of them's 40, one of them's not. So you're thinking that one's 40,
Yes.
and you're thinking that one's 40.
That's not. I wasn't talking about that.
So would it be
Some fun geometry here.
So
the weight down the ramp would be
J hat is weight sine 40. So J hat is up and to the left.
So you're saying that one is theta right there?
No. Well, theta is the angle for theta or for 40?
40.
40
Sorry.
is the one at the top.
That's 40. How'd you get that?
Because that angle is 40 degrees, and then that's
You say this angle here is 40 degrees?
no, the red one is
Okay.
40 degrees.
Yep.
And then it's equal. Like it's a symmetric flip of the triangle. I don't
know, because, that one at the bottom is 90, and that one's 40.
That's 90-degree angle there.
Okay. So the other one has to be 50, right?
So that angle there would have to be 50. That angle there
is 40.
is 40.
Okay.
Oh.
Oh,
I understand.
because it's forming another
Unfortunate.
triangle
Alright.
over the ramp? Is that why?
Yeah, so if I did it slightly differently,
Okay, I
see if I can do this without erasing everything.
Alright.
Okay, I erased more than I wanted.
Wait, what happened? Oh, it's gone.
Is there a way so where you can get it small enough so that whatever you tap is what it gets erased, rather than
Quite possibly. Yes, but.
Wait, how did we get that one?
All right, so weight is acting straight down. So I'm going to draw my weight triangle so that instead of going above my ramp, just sort of cruise it along right there, and I want perpendicular. That's 90 degrees right there. That's 40. That's a right angle right there. So that has to be the complement. And since this is a 90-degree angle, that's got to be 40 degrees there.
Oh yeah. Hey, I have learned how to do this at some point. Oh.
If I let out with some profane word, I apologize in advance. And hopefully we'll edit it out on the video.
I'd say keep it in there.
So this is 40 degrees. Right there.
Okay.
So the part down the ramp is sine.
Sine.
Into the ramp is cosine. And yeah, a mnemonic, I sometimes think, generally the direction of movement, I make it the I-hat direction. I, sine, sort of go together, but then again, cosine also has the long I sound in it. The two one syllables, I and sine.
So if you make I the direction of movement, then sine will always be the direction of movement.
If you're given the angle from the horizontal.
Okay.
So this will be W cosine theta, sorry, 40 degrees. And W sine over here, we would break W10 up. Oh, this is W5.
Okay.
And so over here, we have Y10 going up, FT going also up in the right angle to it, and then W10 sine of theta, W10 cosine of theta. And again, it might be a little bit clearer if I'm under 45 degrees, I make everything look like a 45-degree angle. I'm under 45 degrees there, so you can make it even more accentuated. You make it even more accentuated, then if that's my 40-degree angle there, and I'm breaking this up into perpendicular components, it's a little bit clearer that that's the skinny angle right there. So that one down there would be the same as this.
Oh.
All right, so we've gotten, we're at the equations of motion now.
And then, okay, so for each you need an I hat and a J hat, so I'm assuming you do like I hat, wait, no, W5 I hat and W5 J hat, and then
All right, so I guess these are what I'm labeling as 5, and this is what that is 10.
do we have to label those?
No. It's just in terms of presentation of keeping track of everything, but we do have 4 equations here as was being listed out. So we have our I5 equation, our J5 equation, our I10 equation, the J10 equation, or 1 and 2, or A and B, whatever you're listing it as.
So I hat's going like this. So what
What are you doing,
I
Decker?
5 be FT minus,
You said this one?
yeah,
Okay, FT
minus W5
no,
sine
maybe.
40 degrees
Maybe.
is equal to,
Test that.
is it mg?
Equal to 0.
Equal to 0, that's what it is, my bad. When is it that it's equal to mg? When it's in the y direction?
No, it'd be equal to MA.
MA. But
The only time the force would be equal to mg is when you're talking about weight itself.
oh, okay.
That we'll make a substitution where we'll have an mg in for weight.
Oh yeah, that's what I'm.
But the total force is always going to be mass times acceleration,
Okay.
which is conveniently 0 right now.
And then for the J5 equation, it's the normal force of 5 minus, or sorry, plus, no, minus the, wait.
Would it just be weight 5 cosine 40
Confusing myself.
equals 0?
Because we're in equilibrium.
Yes.
Sorry, acceleration 0. Okay.
Technically, that 0 is 5 kilograms times 0.
Okay.
And Pat, when you said weight, I wasn't sure whether you were about to say weight.
I was about to, I couldn't decide if it was positive or negative in my mind, but I looked at my paper, it's negative.
Yes.
That's how we make rubber and hat.
All right, 2 more equations to go.
And then for I10, or I had 10, I got weight 10 sine of 40 minus the force of tension equals 0.
Weight 10 sine of
theta.
theta.
Yeah. Oh wait. Oh.
Oh, we don't know that angle.
Yeah, we don't.
Is equal to 0, sorry.
Yeah. And then the last equation.
Weight 10 of cosine theta plus the normal force equals 0. The normal force of 10, sorry.
It's killing me that y'all swapped up from doing the
Subtraction.
Yeah,
But no.
There's a mistake, I don't know if I just missed the word or whether, there's a mistake on the board right now, whether I missed it or misspoke.
J hat 10, it's supposed to be Y10 minus W cosine.
Yeah, the big thing is that's negative.
Yeah.
Let me write it, the positives minus the negatives, y10 minus.
Because those are in the positive J.
But putting the negative first is not a problem with that, just.
So why is I-10 like that then? Because
I-10 is-
all the other ones are minus sine 40s. Oh, is it because it's going the other direction?
Yeah.
Okay, got it.
Wait, so if we had I hat going up and to the left instead of down and to the right, would that make it more work for us?
Wait, if we had I-10 going that way,
No, like going that way.
that way?
Yeah.
In this particular problem, as is, where it's in equilibrium, no, it doesn't really add much. But if there's multiple parts to it, which in the original problem, test problem, there were multiple parts.
Okay.
The next part is gonna start accelerating
Oh.
because I'm gonna change one of the angles. And so in that case, it does add to your work if I have I going this way and an I going that way, and it's accelerating, then one of my accelerations is gonna be a negative of the other.
Oh, okay.
So you want them facing, or like kind of going the same way?
Yeah, a general recommendation, I mean, it's not required, but I personally feel it's just slightly easier mentally that way. All right, so we have 4 equations. We're at the first S now.
So substitute. So we have an equation for W.
Yep.
We have an equation for Y, which is, I think it's mg cosine theta.
Well, okay. The substitution phase, it's only for the ones where we have an independent equation. Our equation for Y here is dependent upon this problem.
Oh.
Y is not always going to be W cosine 40 degrees.
Okay.
Yeah.
Let's get some room.
Do we also have an equation for FT or no? Or is that what we're looking for?
Actually, I want to keep this for the next part. No, we don't, there's no independent equation for tension.
Okay.
Let's squeeze it in down here. So we have Ft minus M 5G sine 40 degrees. Actually, I can just do tension is equal to that. Y5 equals M5G cosine 40 degrees. M10 sine theta. Sorry, mg sine theta is equal to tension, and then y10 is equal to m10g cosine theta. These 2 equations right here really don't have any bearing at all on this problem.
Yeah, no. But though they do make things a little easier.
Sorry, Becker, what was that?
They do make things a little easier. So now we got that. We can find FT if we find FT.
Yeah, well, we know our mass
Can
is
find that
5.
angle.
We know our G, and we can find.
Yeah.
So we could actually just stick numbers in at this point and solve for tension and then plug it in down there. I'm gonna do something slightly different, but there's nothing wrong with plugging numbers in when it feels right. But if we just set them equal to each other, so that tension and that tension are the same.
Yeah.
So I have M5G sine of 40 degrees
Okay.
M5G sine of 40 degrees equals M10G sine of theta. It is planet independent.
So is it like we're not on a specific planet right now?
I mean, I was picturing Earth, but it doesn't have to be because G cancels out.
Okay.
Mass 5 divided by mass 10 is 1/2. So I'm left with 1/2 sine of 40 degrees is equal to sine of theta.
Then we just do the sine inverse.
Yeah. So theta is the arc sine. of 1/2 sine of 40 degrees. And if someone would be kind enough,
I got you.
18.74
I
degrees.
got you.
18.75 degrees. 75 degrees.
Huh? So that means that last angle has to be what?
Like, well, a triangle was like 180, so it'd probably be like
the one
120
here?
something. Yeah.
122. Maybe.
Yeah, give or take, yeah.
so
Something like that.
roughly 59 to
121.
yeah, approximately
Yeah.
Okay,
25.
okay.
Yeah, that math.
That is a
lines up.
big angle, okay, that makes sense.
Yeah, don't trust that I'm going to draw it correctly.
Okay. This actually clears it up for me a lot. Is this gonna be like, is this similar to what we'd have on our test, like a level of difficulty, I guess?
This has been a test problem in the past. This was part A of a test
Oh
problem.
yeah, but, okay.
Shall we?
Part A.
Yeah.
Part
Let's-
A.
What the heck? Let's go ahead
Yeah,
and,
what would part B?
Yeah, what's
Yeah.
part B entail?
Well, he said it was like accelerating.
Oh,
That's an arc sign, right?
yes, so I put the A
So,
sign.
so sine divided by sine is arc sine.
Sine to the -1 is arcsine.
That's-
The
It's
inverse. The inverse.
Yeah.
Inverse function.
It's been a while since I've canceled out sines on both sides of the, or one side of the, how to get sine and sine on the same side of the equation.
That sounds
So
like
one
an
side
arrow.
of that.
Okay.
So,
Yeah, I prefer the arc sine over sine to the -1 because to the -1 is to be a reciprocal and not an inverse function.
So the only thing I'm really confused about now is like getting the angle that you had there with like the triangle inside of the ramp. That's like the only thing I'm kind of confused
Oh,
about.
Just-
M1?
Here?
Yeah.
Yeah.
So
Breaking up components.
it's sine over, sine is opposite over hypotenuse, right?
Right.
Yeah.
That's our hypotenuse, and that bottom side is our side. And the angle we're looking for is the opposite, right?
For me, I struggle with identifying which angle is the 40 degrees.
Yeah, that. Yeah.
The trig is okay.
Yeah, so that's why, I've erased it now, but that's why I also, if you're blanking on, the geometry, then if you try to draw it more accurately, or I can hand you a protractor if you really want to go for it, you can draw all the angles perfectly, and then just measure which one's closer to 40 degrees. It's a legitimate technique,
I think
but not necessarily the fastest.
what helped me was when he broke the 90 degree on the side of it there.
Yeah.
So that shows that 40 and
Yeah.
the other degree have to add up to 90.
Yeah.
So that's how I knew that one was 50.
Oh.
And then all that had to add 180. So the other
Yeah.
angle had to be 40.
And also when you identify both as the right angle, and it
Where did you find
it's the rule for how the angle translates over.
Because I think I need to know this.
I forgot what rule that
You
is.
figured something out, but I don't know what.
Not 100% sure which one you're going for.
But I mean, regardless, you're right. Making two right triangles is definitely helpful for
That-
3 right triangles.
I've just now realized what you did. Wow. Okay. Yeah, because 40 plus 90 plus 50, and then on the other side it'd be 40 plus 90, and then 50 at the top. Okay.
Okay. The only thing I was having trouble with is deciding if it was supposed to be sine or cosine. Just because, I don't know. I don't get it, I guess.
Sine is opposite, cosine is adjacent. Oh, if you get into that blank space, not necessarily that some memory trick is going to help you, but if you think about x and y, the traditional x, y, cosine, sine. Cosine, if on a unit circle, cosine's the x value and sine is the y value.
Oh,
So
yeah.
the adjacent. So this is the adjacent, and this is the opposite. There's a pattern here that I haven't pointed out yet, but the x coordinate is also called the abscissa. I think there's a C in there. This is the ordinate. I guess that vocabulary's not taught anymore?
No,
Okay.
I've seen
I
that
don't
word.
even-
I've
Never
seen that
heard that
before.
one time.
Right.
I've
I've
seen
used
abscissa
abscissa and
before.
ordinate. It was either in a lab or a test or a quiz. I've used that term before
Okay.
in the past. So if you run across abscissa and ordinate, notice the pattern here. Oh, we also have horizontal and vertical, alphabetical. These are come first before those alphabetically for each of the pairs.
Oh.
That's what I think of the SOCOTO.
And that's the way that I think most people remember it.
That's what was ringing in my head when I was looking at it.
But some people get the vowels backwards.
Yeah.
I just started using that recently.
So anyway, there's an alphabetical relationship.
That's pretty cool.
All right, other questions before we change the problem slightly?
Do we need to know what abscissa is?
Abscissa?
Abscissa?
Could I just ask you on the test what it is?
Yeah, if I use it.
You can ask.
Okay.
So is that like method of drawing the two right triangles? Is that like work on all of the problems or no? Because that's like really good.
You want all of the problems.
Like I don't like. I know that's kind of vague.
For Maxwell and RAM problems, yeah, that's probably going to work.
Okay.
All the ones I can think of at the moment. If I think of an exception, then that sounds like a test problem.
Makes the exception just so we can't use that method.
Actually, it probably would have just been easier to just do one triangle if you just brought the line straight down, and then we knew that was 40 and it was 90 from that straight down line to the ground,
So that would
and
have,
then you would have known that was 50.
yeah. And then you could have done cosine of 50 and sine of 50.
I'm getting it. This is why you have
Oh.
a doctorate and I don't.
If that works for you. You know, the right one to use is the one that works for you at the moment.
That's fair.
All right, so let's change the problem.
Okay, we'll do that.
I'm down.
I'm now